Okay, hey guys. I'm going to go ahead and start us in section 2.3 with notes, and then I have posted up on the homework website your homework for section 2.2. So we'll do this part of these notes today, and then I'll give you time to work on the 2.2 homework. So they're going to talk about different types of graphs that are available to plot data, some of which are good or enlightening, they call it, and some of which are kind of deceptive. Deceptive graphs occur all the time on the internet, and so we'll see some of those down below. Probably won't get to the deceptive ones until tomorrow. So graphs that enlighten. Let's first talk about the two main ways of plotting data that we've done already. So one of them is a frequency distribution, where we basically have a class over here and then we have the frequency. And so you'll have like from 0 to 9, from 10 to 19, from 20 to 29, etc. And maybe there's 4 here and 8 here and 12 here and blah, 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 all the way through. Okay. So we had frequency distributions, and then we had a histogram, which is basically a graph of a frequency distribution. And so the classes are alongside here, and then the frequency is here. And then we would get bars that are all touching each other and blah, 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 that type of thing, okay? So the histogram is just a graph of a frequency distribution. Now, each one of these has a kind of an order to it, okay? So the frequency distribution has somewhat of an order here. And then, the histogram obviously has order for class down here. So it's going from 0 to 9, 10 to 19, 20 to 29. There is a specific order, so you want to make sure the classes are all in order, okay? Some of the ones down here, like a Pareto chart, we're going to talk about that. That doesn't have specific order to it, okay? So one of the things that's really bad about a frequency distribution is the fact that the original data points, you kind of lose their specific value. So for example, like this first class here, I know that there's 4 numbers that occur that are from 0 to 9, but I don't know what those specific numbers are. Maybe there's 2 6s, a 4, and an 8, okay? Or maybe there's a 1, a 7, a 9, and a 3. Okay, in that. I don't know what those specific numbers are. The only thing I know is that there's 4 of them that live within that class. So you lose the specific values. I'm going to put that here. Lose specific I'm just going to say lose specific values. I just know that there's 4 within that category, okay? So dot plots and stem plots, those are another way, kind of like a histogram will display the shape of the distribution, but also it's usually possible to recreate the original list of data values, okay? With a dot plot, if you kind of look at the way that this is listed here, these are pulse rates of males. So, if this is 50, there are 2 of them that are exactly 50. There's 1, 2, 3, 4, 5 that are probably, I think that value is like 52. You can't see that very well. 52. Okay. This would be 54, 56, 58, 60. So I do have each one of those specific values. Like 60, there was 1, 2, 3, 4, 5, 6, 7. 7 males that had a pulse rate that was exactly 60. So it does tell me the shape, and it's pretty normally distributed, but also I don't lose, they're not listed as classes, so between 50 to 60 or whatever, it does give me specific classes or specific data points, and I know what those values are, okay? So that's one of the things. The original list of data values is kept intact, okay? Over here, stem plot, also, you kind of can see the shape of the distribution, but it's sideways. So here's my bell-shaped curve, kind of. Okay, he's looking something like that. So the shape of the distribution is shown. It also retains the original data values. So the way that this is read, this 4 is here, and then you have the number 0 and the number 2. So my first data value would be 40. My second data value would be 42. Okay, then I have 2 50s. The next one is 52, etc. And I would just keep listing those on out. So those original data values are kept intact. The sample data are sorted, so they are arranged in order. And I guess you could say that over here in this dot plot that those are listed in order as well, okay, from left to right. But so these are also, so they have just taken the same amount of data, the same data values, and they've, over here is a dot plot, over here is a stem plot using the same data, okay? So just kind of different visuals. The important part is both of them are retaining the original list of data values, okay? We don't lose them by sorting them into a class, okay? Time series graph. This is just, this is what you would use if you are given like time periods. So this one is listed as years. So 1985, 1990, 1995, all the way through here. Your year is the x-axis, or I'm going to say year or time is the x-axis. And the y-axis is going to be the number that you are counting. So in this case, it's law enforcement fatalities. That's a big issue in the news right now, is law enforcement and all that stuff. So who knows, the data in 2020 might be way different over here. So this would be kind of interesting to look at, especially with how big this is in the news right now. They've plotted each one of these, probably all of the years. So 1985, 1986, 1987, 88, 89, and then 90 is right here exactly. So you could figure out what each individual year was. You'd probably have to do some estimating. So you wouldn't know maybe the exact data values, but you are given a data point for each year in that time interval. Another time that this graph would be important is, like, let's say you're doing temperature, but you're doing it over months, I guess. Maybe you're doing monthly temperatures, like January's average temperature outside versus February's outside temperature versus, all of those going through here, and you could kind of see how the summer months, the outdoor temperature on average is higher, and so that would be a good time series graph to do. So time series, you're just graphing points over time, whether that be years, whether that be months, days. You could do just about anything that you want to with that, and all of those data points are going to be connected with a straight line. Okay. All right. The next one is a Pareto chart, and I'm going to put a little star by here. I call this a glorified bar graph. Okay. It is basically a bar graph. Okay. It's different than a histogram like we talked about up here. It is a bar graph. And all of these down here are usually categories. So they have, in this one, it says boat thefts. So we're stealing, jet skis get stolen the most often, and then there's a motorboat, a fishing boat. I don't know what all these. Sailboat is the least frequently. I don't know what that one says. I can't read that word. Something board. Anyway, these are thefts of boats. So this Pareto chart, all of these right here are categories, and none of them have a specific order to them. The order that they choose to put them in is from greatest to least. Okay, so specifically, like those 5 categories, there is no specific order to them. Like we were listing the classes, here that have to go in order. There is no, jet ski shouldn't come first before sailboat, other than the fact that there's more. So they would just put the most in this category and the least in the very right category. Okay, so I'm going to say from greatest to least. That's why it is a glorified bar graph. Okay. Just a regular bar graph down here shows the relative distribution of categorical data. So again, these are categories, and none of them are ordinal. You remember nominal versus ordinal. So these would just be nominal data versus ordinal data. So the nominal data is put into an order from greatest to least, but it's not like, the first college versus the 10th college in that order. Okay, so they don't originally have an order before we put numbers to them, okay? Bar graph is categorical data again, so that it is easy to compare the different categories. They don't put a graph on a bar graph because it looks kind of like a Pareto chart, but none of them are put in order. So there's that. And then we have 3 more here. I'm going to go through these real fast and then we will stop. So a frequency polygon is kind of like a histogram, except what they've done here is each one of these points is the midpoint of that category. So these are all the midpoints, okay? And then the frequencies of those. So like on our frequency polygon, or on our frequency chart, when we had 0 to 9, and I think I put 4 here, from 10 to 19, what did I say, 8, and then 12, okay? This was 20 to 29. If those were our data points, what we would have here is, instead of doing like 0 to 9 down here, and the categories like that, I would choose the midpoint. And the midpoint is going to be 4.5, and I would label that as 4 here, and I would put a dot on it, okay? The midpoint of 10 to 19 would be 14.5, and that would be up here at 8, okay? 20 to 29 would be 24.5, and that would be up here at 12, okay? So they use the class midpoint for these categories down here. I should put an arrow there instead of an arrow. Sorry. These are your class midpoints, okay? And then the frequency is just the normal frequency that they had on the table, okay? And then you connect your dots with a line, and it just kind of makes a nice, you know, midpoint. You can kind of see, rather than doing bars like the histogram does, it gives you kind of a nice line graph in that way, okay? So frequency polygon, each one of these graphs that we have here, we're going to do some practice actually making some of them with some actual data here in a couple days. So kind of be prepared for that. So frequency polygon, that's what that guy is. All right, a relative frequency polygon is the same thing. It's just comparing 2 different things. And it is percentage. Like 5 minutes. Okay, my kid is crying, sorry. So this one is comparing 2 different things, McDonald's service times and Dunkin' Donuts that we talked about before. And since it is relative, that relative means we're dealing in percent, okay? So they have taken each one of these frequencies, and rather than doing the frequency, like here, there is, let's see, 4 plus 8 plus 12 is 24, I think. So to figure out this as a percentage, they would do 4 over 24, which is 1/6, so like I think 1/6 is 0.16 actually. So 16%, 8 over 24 is 1/3, so 0.33. And then this guy would be half, 0.5 or 0.50. So we would take each one of those, and these would be labeled with the percentages rather than 12, 8, and 4. Okay, so that's what they've kind of done over here, and you can kind of see those trends. These again are your class midpoints. I can't go over that far. Midpoints. And then you can kind of see, that's another visual display of having the lines on top of each other, and they're comparing 2 different things, Dunkin' Donuts versus McDonald's. Those are the drive-in times, and again, we can kind of conclude that Dunkin' Donuts has faster drive-in times. So you would wait less in line for that, okay? So that's another one that we haven't really... You don't really learn that as a graph in elementary school. The main graphs are going to be a bar graph, a pie graph, you know, those types of things. So frequency polygons are ones that you're not going to be as familiar with, okay? So this one's relative because it's percentage, okay? So that's a really important part. And then there's the good old famous pie chart, okay? Usually when we do pie charts, this one is not set up this way, but usually when we do a pie chart, your first category will always start here, like those of you who have had trig before, we always start with the positive x-axis being kind of our standard point, and then the largest chunk is the first chunk that goes. So like maybe this is my largest piece, largest, and then they get smaller from that. So a smaller chunk, whatever, you get the idea. Let's make this one that small, and that small, and that small, and that small. Okay, so they kind of do that from largest to smallest going all the way around. That's kind of how we make our pie charts. It says shows the distribution of categorical data. So these are all categories again in commonly used formats. So we might do this as like eye color. So the biggest section, maybe it's most people have blue eye color, and then maybe it's brown, and then maybe green, and then maybe hazel. And we really only have mainly those 4 eye colors. So, whatever. We could do this again as like, the fraction of seniors that we have versus the fraction of juniors that we have. I don't know. The senior class, I think, senior class and freshman class, I want to say, are maybe the largest classes. So you would have like the senior class being a pretty big chunk, the freshman class being a pretty big chunk, and then the other one's kind of smaller from there if we're looking at the whole. But the thing that a pie chart is used for is it displays fractions of a whole. So here we were talking about the whole population of people, and then the fraction that has blue eyes, brown eyes, green eyes, hazel eyes. The whole group of Blue Hill High School students, and then the fraction that are seniors, juniors, sophomores, freshmen, that type of thing. Okay, so they've taken that same data here, the sailboats, the jet skis, that type of thing, and they've graphed those on a pie chart. Now, you will not be able to graph the same data on every single graph. For example, like a pie chart, you would not be able to use like the sailboat jet ski data to make a time series graph, right? Because there's no time that's involved with the sailboats unless you had access to like the months that boats were stolen, and maybe you could see that more boats were stolen in the summer months than any of the other months. Yeah, like this data right here in the Pareto chart, that was the jet ski stuff. You wouldn't be able to graph the same stuff on a time series graph versus a Pareto chart. This data could easily be represented as a pie chart as well. So you can kind of pick and choose which graph you want to use for that. But some of the data is better as a time series graph. Some of the data is better as a pie graph, etc. Okay, so there was a lot of graphs on here. We'll review all of that again tomorrow, and then we'll kind of do an activity with that hopefully in the next couple days. Okay, go on and do the homework for section 2.2, and we will reconvene tomorrow.